All right, we're going to talk about, what did I say?
Thread
repair and hardware. Okay. Here we go. Monday, right?
I thought it was Tuesday.
Don't start, Tim. Okay, so here's a representation of taps and dies. Why don't I not have my nice little laser pointer? There we go. Laser pointer, taps and dies. These lined up right here are taps, and these are dies. All right, I like these dies a little more than the ones that you guys get in the other in the lab, because they're not split, or I like the ones that have a single split. But that's just me, right? All right, we don't need to see that now, do we? Just wondering what kind of slides I had here.
Are those even adjustable though? No.
So what class are those cut to?
Whatever. Whatever size. That's what size. Oh, my slides are all messed up here. Okay, so I guess one of the first things we need to talk about really is when we talk about taps, dies, and threads, we have to understand that there's a certain pitch to them. In other words, or a thread per inch. So this is at table 7-1 out of what book?
AC 4313.
All right, which is that approved data? It's acceptable data. So if we take a look at this chart, what is this chart? You guys should all know what this is already. It's torque values, but let's stop and take a minute and actually see what it is. Caution, the following torque values are derived from oil-free cadmium-plated threads. All right, so first of all, what is cadmium? It's that stuff they make little Easter eggs out of. We know that.
Cadmium eggs.
Yes, they're cadmium.
It's anti-corrosive.
It's a plating. It's like chrome is a plating. Well, this is a plating. In fact, we used to. I can't say it.
Is it kind of yellowish?
Okay, so way back in the day, I don't know how much trouble I get for this one. We used to have we worked on antique engines, and so you really couldn't get this hardware anymore, so it was just done different. So we would take the hardware and we'd bead blast it and get all the plating off, then we'd take it downtown to a plating shop, and depending on the engine and the year, it would either be CAD plated clear or CAD plated gold. So there's different kind of CAD plating. That's just really what's common in aviation hardware. I don't think that would be appropriate anymore to do that. But so tell you that to say that hardware is either a gold plated, steel is either the gold plated, or it could be CAD plated clear, which is silver. There's also corrosion resistant, which is stainless steel, which looks like your silverware at home, unless you have a lot of money. Tim, you guys rich? You have actual silver? Tim does, personally. Okay, so this only counts for oil-free cadmium-plated threads. What if I have aluminum bolt? Does this work? No. What if it is not CAD-plated? No. Also, notice it's thread size tension-type nuts, and they give an and. It doesn't really say anything about like these two. It's really just those two bolts. And then we have shear type. We'll get more into that. Fine threads and coarse threads. Almost all threads in aviation airframe are fine thread. Almost all. I don't know if I've ever seen a coarse thread. It'd be extremely rare to find a coarse thread in an airframe. Engines, like I said, Continental, they're pretty much all fine thread. Lycoming pretty much went all coarse thread. That's just where they did that. So we have to be aware of these thread sizes, and you can see them going down here. If I have a particular bolt and I measure it and it has 28 threads per inch, well, then it's probably a quarter 28. A quarter 20 has 20 threads per inch, so a coarse has fewer threads per inch than the corresponding fine thread.
When it says oil-free, is that just like a non-wet torque? Or
It's dry, absolutely dry. We'll talk about it again, but in engines I go into great detail about that. But you lose, it's about a difference of 40% between oil and not having oil, so it's a big difference. All right, get into taps. We'll talk about hydraulic fittings. Hydraulic fittings are very difficult to deal with. For example, an 1/8 inch NPT is National Pipe Thread. 1/8 inch pipe thread is about the size of my pen. So that's 1/8 inch. There's nothing about that is 1/8 inch. Where they get it, I honestly don't know. But Prince will probably tell me. But but it's big. It doesn't measure 1/8. Nothing about it is 1/8 inch. And so it's really kind of weird. So this is out of Genuine Aircraft Hardware. They actually have a page that's printed about the right size, but I was working with Shrey, and I'm like, well, she gave me something, well, like matches the 3/16, but it's really a dash 4. So you got to make sure that that fits just inside the silhouette, not exactly on it. Anyway, so if you have something that you're trying to size out, flare and AN fittings, sorry. This is what we refer to as AN fittings, and I'll get into those later for hose fittings. All right, back to threads per inch. So one of the projects that you have in lab is that you will have a box of unknown hardware and a little tag, and you have to figure out what it is. And when you're looking at various threads and you have this thread pitch gauge, I really don't recommend just starting here and going all the way through until you get the right one. Measure it, take a good guess, and let's just say you come up with the guess and it's, well, I'm not sure. It's either a 10, which is also, what size is a 10 from 309? Do you remember? It's 3/16. So 3/16, 32, quarter, or 5/16. So you know it's one of those. You only have to try 3 things. It's either 32, a 28, or 24. And if it happens to be 28 threads per inch, then it must be quarter inch. I don't even think there are any other 28s. So there you go. All right. So back to taps here. So tap is used to create internal threads. And there are pretty much 3 types of taps here. So we got taper tap, plug tap, and bottom tap. So notice here we have 7 threads are chamfered. So 1, 2, 3, 4, 5, 6, 7. So all the way back into here it's chamfered. This has only got 4 chamfered threads, and this has only got 1.5. What do you suppose each one of them is for? Good. I'm glad. Good answer.
One's for a blind hole.
Okay, one's for a blind hole. Thank you. That's exactly right. All right. So the project you actually have the luxury of taking a piece of aluminum and going all the way through.
Yep.
So if you're going to do that, you're going to want something like this taper tap, because what it does is it helps to start in the hole, and it kind of self-centers. It doesn't kind of actually self-centers, and it sort of wants to find its own vertical, or it sits in the hole very square. Unless you force it off, it pretty much will find itself and go down nice and straight. And so that's what that's for. But if you have a blind hole, now a blind hole, it means that the bottom doesn't go through. So you actually go to the bottom of a hole, like a lot of stuff in engines will do that. And so if you were to do that, you would be how many threads shy of actually running a bolt in? 7 threads. That wouldn't be a good idea, right? So you'd run this one through, you'd start the threads, so you'd get a good set of threads up near the top of the hole. Then you can switch, you can run it one more time with this, which will cut hole threads nearly to the bottom, then switch to a bottoming tap, which will be 1.5 threads from proper on the bottom. You would never start with the bottoming tap. It's really hard to start with. So unless you're working in a production setting, then I would just go from this one to this one, which is what I do. All right, so those are our different types of taps. Yeah, let's stop there and write some notes. How's that sound? All right, tap and die. Who are my King of the Hill fans?
God damn it, Bobby.
What's that?
Said God damn it, Bobby.
Got. This is Got, G-O-T.
Yeah, it's almost every night.
Got to go down to the Megalo Mart, get me some WD-40 and a tap and die. All right, I'll play that one at break. Tap and die. All right. Definition. Well, a tap is used to create what kind of threads? Internal, external?
Internal.
Internal threads. In a hole. Just to be very specific here. All right, a die The dye is used to create external threads. Like on round stock. On round stock. All right, even though your project has you taking some aluminum rod and threading it, making some class 3 threads, I cannot think of a single instance where you would ever do something like that in aviation. Well, let's just say you needed a few more threads on your AN bolt. So can you just cut a few more threads? No. Negative. We're going to get into why, but it's just not done. Really, where would you be doing a lot of tapping and dyeing in aviation? Nope. If you're doing that, you're already done screwing up in and of itself.
At the manufacturer?
Huh?
Manufacturer?
You need to make a lot of tools.
First,
Make a lot of tools in aviation.
You strip out holes?
No, you're making tools. Making
No, I
tools.
meant you use it when you strip out.
No, I mean you will actually be making a tool, and you might need a rod and cut some threads and tap a hole, and you do a lot of that in aviation. Now thread repair, that's a different story. But as far as actually cutting and tapping and creating stuff like that, it's not called for very often on an actual aircraft.
What was that last part said?
On round stock, I ran out of room. So. All right. So we have thread types. Thread types. Sometimes I write things I probably don't need to. There are different thread types. There are different types of threads. All right, what are my different types of threads? Fine and coarse, okay. There's more than that. Unified thread standards. UTS. UTS. Which are considered parallel threads. They are defined into national course, and united course, which is NC and UNC. They are actually different types of course threads. Although you're going to find that a lot of them are the same. I believe these two are exactly the same. There is National Fine. And United Fine. That'd be NF and UNF. So you might actually see, you're going to see this in places. You have a thread pitch or something like that, and it'll just say NC, or it'll say UNC, NF, or UNF. And now you know what that means, right? NC is what? UNF is what?
United.
All right. What's the difference? The only difference is the U. Is
Yeah.
that'll be on the test. Is that NF, National Fine, has a 1 inch by 14 threads, while UNF has a 1 inch by 12 threads per inch. TPI is thread per inch. Threads per inch. That's the only difference. Otherwise, everything's the same. People watching at home are going, where did you just go? I disappeared. I'm back. My shoe was untied.
Except for twice
Right.
now.
Per inch.
Threads per inch. Per inch. None of this millimeter stuff here. I do not think there are any FA questions that get into metric stuff, so we're pretty much sticking with standard. All right, we have that. We have United National Extra Fine. Which is NEF, NEF, United Extra Fine, and United National Extra Fine. I don't even get it. I don't even get into these. Neither does the FA. So I'm just going to tell you that they're there, so I don't confuse you. And United Special. I should find some examples of this. UNS. So what are we going to mostly be working with here out of all of these?
UT.
National Fine. Pretty much National Fine.
Oh,
Yeah.
I have kind of this question. So when you mean by threads per inch TPI, so do you mean by every 1 inch of distance there's 12 threads?
Yes, that's exactly what I mean. Good question. And a good segue. All right. Where was I? Ah, now we've got National Pipe. Or NPT. And it uses a taper thread. All right, this requires some discussion. All right, so looking at this chart down here, the National Pipe, NPT, National Pipe threads, TPI equals threads per inch. All right, let's take a look at this. So we have 27 threads per inch, 18, 18, 14, 14, 15. I don't know exactly which one of these, but believe it or not, it will fit in, it will kind of correspond to some bolt sizes. And we can look up here, these are flared fittings. These are not pipe fittings. So this up here is flared, this down here is pipe. Let's see if we can match up one. 12, 16, 16, 14. Some of these will kind of match up to some of these. I think it's just close enough to where it does. These pipe threads are not made to go into a flared fitting. Flared fittings are not made to go into pipe fittings. Pipe fittings are not made to go into threads for bolts, and flares are not made to go into those. However, going into our next semester, I will see all. Who are my people who have already had who had 312, 313? All right, props to you guys. Probably one of the best classes so far. Christian's still got his hand down. Props. His hand level's a bit higher.
I completed it.
All right. One of the best classes I had for not messing things up. Before this, I have got classes shoving anything that'll fit into a hole with a wrench, a crescent adjustable wrench, in there and just twisting until something either breaks, cracks, or it comes to me and says, "Why is it leaking all over the floor?" Because you shoved one of these into one of these, and it just doesn't work that way. Okay, so these are all different things designed for different applications. They are not something that is going to cross over. All right, so now looking at these, except if you're watching on the YouTube, you cannot see this right here. So,
See what you pointed at.
I know. So I got to make it, I don't know if I can make it, move this one up here.
That's fine. Nobody's really
I'll
watching.
make this one down. It's just all part of what I got to do, right? Just got to, remember, because maybe Christian's at home watching or something. We got to,
Oh, he's right
Okay.
here.
I feel better.
all right. We were talking about you last week, I'm sure.
Yeah.
Okay.
I can talk about me.
So we're looking at these three things. What do we have down here? They are hoses. All right, we're off to a good start. And you're going to have hoses later, but you're going to be working with some hoses before you get there, so I don't want you messing things up. So a hose with this type of fitting is designed to go on one of these, and it's got a little flare right here. All right? And this nut is for a bulkhead fitting. I'll have to just explain that later. Basically, so this and this, and this, and this. They're all the same. And they're going to go on a hose. Okay. They're going to go on a hose. What about this?
It goes to the coupling.
Pipe.
This is pipe. Notice how it's tapered. It's much thinner here than here.
Yeah.
So the way pipe works is this is all right. It's been cut with a die, and so we've got tapered threads. So it's going to start small here and get bigger here. Now the hole that it's going to going into is going to start small. Get big and get smaller. So when you first engage it, it's going to be very sloppy loose. And so this thing, which is tapered, is going to go into a hole that is tapered. And the more you go in, the tighter it's going to get. And that's how you get the fluid tight fitting out of it, is you just smash them together until they stop dripping. Now, what happens if I tighten it to it stops dripping and decide to give it a couple more turns?
It's gonna crack.
It's going to crack because this is a wedge shape. And the more I drive that wedge shape into the hole has to open up. It forces it to open up. Now, when you're working on aircraft and you do that until it cracks, guess what you do?
Break the airplane.
You just buy a new fit. You just buy a new whatever you cracked. So, like if this is going, like a carburetor would have something like this. So if you're screwing this into the carburetor and you crack the carburetor, what do?
Buy a new carburetor.
You just buy a new carburetor, and they're not really that expensive in comparison. I mean, well, you know, a carburetor for 150 is probably not going to cost you more than $2,000. So,
Oh, that's pocket
As
change.
opposed to an engine, what,
yeah.
23,
All right.
30,000?
This might be a confusing thing. This nut right here is actually going to be about the same size threads here, but it is a bulkhead fitting. This is designed so that this goes through a piece of aluminum and this tightens down and locks it in place. It's not part of the sealing process. All right, so those all don't go together. Oh, here, okay, quiz time. What is this right here?
Pipe.
Pipe, and this is
Pipe to hose.
pipe to hose. All right.
Why is that called flared and not chamfered?
Okay, so when we had the committee, we all met together.
You guys beat up the feathers.
And it was close. I mean, it was close. There was 13 people on the committee. It came down to the tiebreaker. So what was the question?
It's called a flare, but it's chamfered.
Okay, because the component that goes on it has a flare.
Okay.
And that was really the point of the committee, and we all got just kidding. All right.
You were on a
Where's
committee
my
for something?
no? Just teasing him. All right. So by the way, what degree is this right here?
What?
37.
37.
It's roughly about 37 degrees. Anybody know what automotive is?
37 degrees?
It is not.
I was
No,
close.
45. So AN flares are not the same as automotive. So you need a different tool, and everything is different. I knew a guy who just used a 45. Like, it'll fit. It'll conform. Don't do that. Huh? Yeah, use flaring tool. You'll learn to use all of these things in the second year. But like I said, my goal right now is for you to be familiar with them and the threads per inch, and know that you cannot force these things together. So, for example, what do I see a lot of? I see a lot of people forcing this hose onto that fitting. Will it work?
No.
For the first couple threads.
It kind of sticks a little bit, but it leaks really bad. And you'd be like, well, I don't understand why it's leaking. What seals? Hey, you need more Teflon tape. That didn't work. Electrical. What seals this hose onto this fitting?
The tapers matching.
The cones match together, right? That's what it does. Okay. So if you don't have the cone, and what seals this?
Tightness, the expansion.
The expansion of the threads going in. Okay. So make sure you're putting the right thing together. That's more for, yeah.
That photo, there's colors on them. Do those colors mean?
Oh, these colors do mean something. That's a great question. They are color coded. This is blue. That means that it is aluminum. If it were black, that means it's steel. And that it matters. There are some ADs out there where you have to actually take out the aluminum and put in steel. There is one exception to this whole rule that I told you that I know about. And it actually uses this very fitting right here. And while I'm thinking about it, and fuel pumps. So if you look at a carburetor, you look at any component, almost always, if it's got some sort of thread boss that is going to accept one of these fittings, AN fittings, it is always going to be, which one do you think? You have a boss. A boss means a hole with threads, okay? And it's going to accept a fitting. What am I, a carburetor, for
It's
example?
gonna be this
It can be
Pipe thread.
pipe or a hose going into the component.
pipe.
Pipe.
You're right. It's always going to, almost always going to be pipe thread. And again, I'm getting outside of how much Teflon tape do you put on this stuff? Is absolutely this much. All right. I use Teflon paste, but you don't use Teflon tape because it can get into the jets and the carburetor jets and other components, ruin them. Okay, so pretty much with one exception that I've ever seen, that's always going to be the case. You have a boss on a component. You've got a hydraulic pump. It's going to take pipe threads. You have a carburetor, pipe threads. Pumps, on and on and on. AC pumps or diaphragm pumps do not. They actually take this. They are set up to take this with this nut. And so you screw it in as far as you want until this is angled in the right direction. And then an O-ring goes right here, and you turn this nut towards the flare, which was not its original design, with an O-ring, and it seals it that way.
Well,
And then-
normally you put the O-ring on there, tighten it down, you roll the O-ring, get it all back together, and then it leaks, and then you're pissed.
So, but anyway, that's the exception. So, yeah, I had a problem with somebody. Like, I don't, trying to order. They ordered like pulling their hair out. I can't find the right fitting. I can't order them anymore, and I got to get a whole new pump because I can't get the fittings to go in the side. Like, well, it's just an AN fitting, just any one of them. That's all it is. I'm like, no, you're wrong. Okay, never mind that. So, all right, so we got that going. Threads per inch. How many threads? If this is 1 inch,
14.
there would be 14
threads.
threads. But there's 1, 2, 3, 4, 5, 6, 7. So how far is it from right here to right here?
Half an inch.
Half an inch. Oh, look at you guys. All right. 14 threads per
Notice
inch.
Chris didn't say anything.
All right, let's go back to here. Is it break time? It is break time. Oh, thank God. I thought it'd never show up.